Second module on computational biology. In this DNA sequences for similarity. Sequence similarity is an important parameter which is utilized to distinguish between two genes which may have been derived from different organisms. In order to use the basic local alignment search tool, nucleotide, designated as BLAST-N. This algorithm facilitates the comparison of two sequences and identifies gaps as well as identities between these two DNA sequences. You can access the URL for the BLAST algorithm, which is available at the NCBI Resource Center. Among the different kinds of BLAST algorithms available at the NCBI Resource Center are the nucleotide BLAST, which can be utilized to compare two nucleotide or DNA sequences, the protein BLAST, which can be utilized to compare two amino acid sequences, the BLAST-TX, which translates a nucleotide query into the amino acid sequence and compares it to the protein database, the T-BLAST-TN and the T-BLAST-TX, which have their respective functions as stated in the slide. Today we will be using nucleotide BLAST to compare two DNA sequences. In order to compare two DNA sequences, we need to key in the accession number of the sequence which we want to compare and run it using the BLAST algorithm. In today's exercise, we will be retrieving the sequence M63713 and comparing it with those available at the NCBI Gene Bank. The DNA sequence CDS represents the growth hormone which was retrieved in the earlier module. After keying in the sequence, click on the BLAST button. The search algorithm will return the results in a graphic format, with red representing the highest degree of similarity and black representing the low level of similarity. For instance, in this slide you can see that most of the sequences are red. However, there are some sections which are in purple which have a lower level of similarity to the original search sequence. In this slide, the word query represents your search sequence and the subject represents the target sequence which it has hit at the NCBI Gene Bank. Among the parameters which are recorded are the identities, the expect value, and the gaps. In this case, the DNA sequences are almost 100% identical, as 602 of the 603 bases are similar. And the low number of gaps, which is in this case 0, indicates that the sequences comprise an intact open reading frame. Parameters which you should be addressing when you compare two sequences. The first is the expect value, the second is the number of identities, and the third is the number of gaps. Please complete your evaluation at the end of this section. Thank you.